Okay, so 7 says operations on functions. So if we have two functions, we can do a multiple of things with them. So it says let f of x and g of x be any two functions. Remember, a function will pass the vertical line test. So we have two functions going on, and we can add them together. So if you see f plus g of x, that's just a fancy way of writing f of x plus g of x. We're going to add our two functions together. And if you see a minus sign with it, then I'm going to subtract my two functions. Just be very careful and use lots of parentheses because we're subtracting the whole function. Okay? So we have to distribute a negative. If you see this guy right here, f times g of x, that really just means I'm going to multiply my functions together. So you're going to be doing some FOILing or lattice if you need to. And then f divided by g of x is just, I'm going to take my two functions and divide them. Okay, so number 1 there says, given my function f of x is 3x squared plus 7x, and g of x is 2x squared minus x minus 1, find each function. So all we're really doing on this guy is I'm adding my two functions together. That would be the same thing as saying f of x plus g of x. And then I'm going to replace it. Get in your brain today, replacing. We're doing lots of replacing. Okay? So I'm replacing f of x with what he equals, and g of x with what he equals. And I'm going to use parentheses so that you can see it. And now, let's combine like terms. So I got a 3x squared and a 2x squared. So I have 5x squared. And then I have a 7x and a negative 1, so I have plus 6x. And then a negative 1 that just gets to chill. Remember, just like before, we don't do anything with that left-hand side. We just kind of simplify the right-hand side. Make sense? So we just take our two functions and add them together and combine like terms. Questions on that one? Okay, so then like I said, be careful with the minus sign because this guy really means f of x minus g of x, my whole g function. So again, I'm going to replace f of x with what he equals. 3x squared plus 7x. And I'm going to replace my whole g function with what he equals minus 2x squared minus x minus 1. Now, remember, you're subtracting the 2x squared. You're subtracting a negative x and you're subtracting a negative 1. So distribute your negative. So when you distribute your negative, you got 3x squared minus 2x squared, so I got 1x squared. 7x plus 1 more x gives me an 8x. And then I get a plus 1. Questions about either one of those two? Okay, number 2 says f of x equals 3x squared minus 2x plus 1, and g of x now equals x minus 4. Find each one. So this guy right here says I'm going to multiply them. So f of x times g of x. This is where we're going to have to do some FOILing or distributing or use a lattice or whatever you're comfortable doing. So again, I'm going to replace f of x with what he equals. And I'm going to replace g of x with what he equals. For lack of space, would it be okay if I just distributed? Okay, here we go. If you want to use a lattice, you certainly may. 3x to the third minus 12x squared minus 2x squared plus 8x plus 1x minus 4. And then finally combine like terms, so 3x cubed minus 14x squared plus 9x minus 4. Okay, then letter B says take f divided by g of x. This one is my favorite. I hope it's your favorite too. So again, I'm going to replace my f function with what he equals, my g function with what he equals. So my f function is 3x squared minus 2x plus 1. And my g function is x minus 4. That's it. Now, sometimes you'll see it and it'll say that. You just have to write it, right? Is there something, though, that would cause problems? Is there some number, if I plugged it in for x, that would cause problems? Meaning, uh-oh, I can't do that. What's the thing I can't divide by? 0, right? So if I can't divide by 0, so what value would make this guy 0 in the bottom? 4. So sometimes, and I'm not going to make you do it, sometimes you'll see that it says x cannot be equal to 4. Because if x were equal to 4, we'd have uh-oh divided by 0, tornadoes with a hurricane and a lightning bolt. Everything bad that ever happens in math happens right there, right? If it were before. Okay? So, like I said, I'm not going to make you do that part, but we can't have 4 because then we would divide by 0. So I like the division one the best because you just have to write it. Questions on those 4? So we can add functions, we can subtract functions, we can multiply them, and we can divide them. Okay, the next part is the composition of functions. Now, remember in your brain the word replace, okay? Try to think about replacing today. Remember replace. Replace, replace, replace. So, the composition of functions, it looks like the word fog, but it says f of g of x. It really means f of g of x. It's read as f of g of x. think about putting one function into another one. Okay? I'm going to put my g function into my f function and replace it. Okay? Okay. We can do the composition of a relation. So remember a relation is just a set of ordered pairs. So there in number 3, it says, I've got my f relation, my g relation. It says find f of g of x and g of f of x if they exist. Sometimes they don't exist. These ones I think are a little bit easier than when we do it with a function. Okay, so here we go. Let's start with this one. F of g of x. That really means that I can't write f of g of x. The other thing I want you to think about is going from the inside out or from right to left. I want to look at my g function first. Then I'll look at my f function. Okay? On this guy, I'm going to look at my f function, then I'll look at my g function. So think about inside out or Chinese right to left. Either way. Whatever makes sense to you. But this guy says I'm going to start with my g function. Okay? Here's my g function. He's green. I'm going to start with my g function, and look at these guys are called a mapping, right? Ordered pairs are we call them a mapping, if you will. 7 goes to 0. Okay. Where does 0 go to in my f function? 7 goes to 0. Where does 0 go in my other function? -1. Okay, let's do another one. -1 goes to 7, so I'm going to start at -1. -1 goes to 7, then I switch functions and I find 7. 7 goes to 7. That guy didn't change. Okay, next one. 4 goes to 9. Switch functions. 9 goes to 4. You're kind of cutting out the middleman, right? 4 goes to 9, 9 goes to 4. I get rid of the 9s. One more. 8. I'm going to start at 8. 8 goes to 2. Just so happens they're in backwards order. Doesn't always work like that. 2 then goes to 6. Okay, now it said, questions on that before I do any more. Okay, then it says find g of f of x. Again, start with the inside. I'm now going to start with my f function and then go to my g function. See, I started here with my g function and I went to my f. This one I'm going to start with my f and then go to my g. Okay, here we go. I'm going to start with 2. 2 goes to 6. Where does 6 go in my g? There isn't one. He doesn't have a mapping. You can stop. there's no composition of functions for that guy. Does that make sense? Okay, questions on those? Now, if 6 would have gone somewhere over here, then we would have done 2 comma whatever. Does that make sense? Do you want me to show you if we didn't have that guy, what would happen? Well, 9 would go to 4, and then 4 goes to 9. So we would have 9 comma 9. Does that make sense? 7 goes to 7, 7 goes to 0. Negative 0 goes to negative 1 goes to 7. Questions on that? Thomas.
So why doesn't the simplify this?
You're good. So 2 goes to 6, but in my other function, there's no 6. There's no 6 comma whatever in this here, so I have nowhere for it to go. Oh, you can't see it, I'm sorry. Does that help? Okay. Okay, let's try it now with a function. Yeah, sorry, Shina. So we're getting to a point where we can find inverses of functions. So we have to know what the composition is in order to find out if it's an inverse. So we're getting to the point where we want to talk about inverse functions, and inverse functions we use when we're graphing all kinds of things. So in order to know if something has an inverse or if they are inverses of each other, we have to know the composition. Does that help? Okay, good question. Okay, so on number 4 there, it says, for f of x equals 4 of x and g of x equals 2x minus 1, find f of g of x and g of f of x. All right, let's start with this guy. F of g of x. Again, it looks like fog, but that really means f of g of x. Again, think inside out. Or replace. I'm going to replace g of x with what he equals. Okay, I can do that. Well, g of x is 2x minus 1. Have you done that before? Have you done f of 2x minus 1? Yeah, we did that way back in the beginning of the chapter, right? I gave you a function and I told you to plug something into it. That's what we're doing now. Everywhere there's an x in my f function, I'm going to replace it with 2x minus 1. Again, think about replace. So this guy is 4 times 2x minus 1. We're plugging one function into the other one everywhere there's an x. So if I simplify that guy, I get 8x minus 4. Okay, there's 1. So we had to go both ways. So g of f of x is g of f of x. I'm going to replace f of x with what he equals. So this guy is g of 4x. Again, you've done that part before. We did it in 7-1. So everywhere there's an x in my g function, I'm going to replace him with a 4x. So this guy is different. He's 8x minus 1. You should end up with two distinct things when you do both functions. Okay? F of x, f of g of x should look different than g of f of x. So, just look at what we did. I plugged this guy everywhere he had an x. I plugged this guy everywhere he had an x. You're replacing it. That's why I wanted you to think about replace. And think about going inside out. Questions? Or clear as mud, I wouldn't even know what to ask you right now. Okay, let's try another one. Okay, here we go. F of g of x. F of g of x. Replace g of x with what he equals. 2x minus 1. Oh, that didn't change from the last one. So in my f function, everywhere I have an x, I'm going to replace him with 2x minus 1. Ooh, this guy's going to require some more paper. So I just want you to see that you can write it this way. So if you just want to skip that part and go to here, I think this is easier to see that it replaces. So I want to plug 2x minus 1 into my f function. So if you don't want to write that part, JJ, you don't have to. Remember, we're just trying to simplify all one side. We're not going to cross an equal sign or anything like that. Okay. This guy right here is going to require me to FOIL. Sorry, I didn't give you enough room on this one. This one is going to require me to distribute a negative. Would it be okay if I did that right now? Got a minus 2x plus 1 plus 4. Okay, let's FOIL. FOIL first, and then we'll take care of that 3. 2x times 2x is 4x squared. 2x times a negative 1 is negative 2x. Negative 1 times 2x is another negative 2x. Negative 1 times a negative 1, positive 1. Minus 2x, I'm going to combine those guys and save some time, plus 5. Three, 4x squared minus 4x plus 1. Again, if you can do that all in one step, I'm fine with that. 12x squared minus 12x plus 3 minus 2x plus 5. I'll stop. I was going real fast there. Sorry. Head down and in the zone. So that I get 12x squared minus 14x plus 8. That was a lot. So I plugged my g function into my f function. That's f of g of x. Now we got to go the other way. So now I'm going to take my f function, the whole shebang, and plug it into my g function. Again, I'm replacing with what e equals. So I have f of x equals 3x squared minus x plus 4. So everywhere I see an x in my g function, I'm going to replace it with 3x squared minus x plus 4. This one's a whole lot better, right? Because we only have one x to replace. So this guy is now 2 times 3x squared minus x plus 4 minus 1. To distribute the 2, so it takes it to here. My tongue got in the way. 6x squared minus 2x plus 8 minus 1. So finally, 6x squared minus 2x plus 7. See how we got two distinct functions? They shouldn't look the same. Questions? Okay, last thing. Let's look at number 6. These are a whole lot easier. Think about plugging a number into a function, right? Again, think back to the very first section. We did those. We did this, right? We did g of 1. I said find g of 1. And then we found it. Not a whole lot has changed. These should go pretty fast. Okay? Again, think about going inside out and you're replacing it. So I'm going to start with g of 1. So if I plug 1 into my g function, I have f of x equals x squared, g of x equals 5x, and h of x equals x plus 4. So I'm going to go to my g equation and replace the x with 1. Well, what's 5 times 1? 5. Whatever number you get, you are now going to put that into the outside function, or the f function, or the leftmost function. So now I'm going to say f of 5. So into my f function, I'm going to replace everywhere there's an x with 5. So 5 squared. So f of g of 1 is 25. Okay, you try letter B. You're going to plug -2 into the h function. Whatever number you get from that, plug that into your g function. Okay, most of you got it. The ones I checked or saw got it. I'm going to plug negative 2 into my h function. So negative 2 plus 4 is positive 2. Now I'm going to plug 2 into my g function. 5 times 2 is 10. Sound good? Questions? Thomas.
What's the point of it? Are you going to use this in another section, or is this to kind of extend?
We'll use this here tomorrow. There goes math, right? Okay, turn the page. Let's look at your worksheet. Okay, so at the top, you're finding f plus, you're adding your f functions together, you're subtracting your functions, you're multiplying them, and you're dividing them. How many answers should you have for each question? 4. I want you to go ahead and skip number 4 because it's grody. Skip number 4. With that x in the denominator, gross. Who wants to do that? Okay? Number 5, 6, 7, and 8. You're doing the mapping. So you're going to find f of g and g of f. You're going to start with the g function. 0 goes to 4, 4 goes to negative 2. That make sense? Number 9, 10, 11, 12, and 13, 9 through 14. You're doing the composition. You're going to do g of h of x and h of g of x. Looks like it spells hog. Okay? You should have 2 answers for both of those. You're going to take your h function and plug it into your g function. Replace it. Then you're going to take your g function and plug it into your h function. Replace it. Then at the bottom, these ones, like I said, should go fairly fast. You're going to plug 1 into your g function. Whatever you get, plug it into your f function. These should all be numbers down here at the bottom. Okay, what about this guy? Let's look at 22. Yowzer, right? It's not as crazy as it looks. Start with this. What's g of 1? If I plug 1 into my g function, what do you get? 5. Okay, I did that. Now I'm going to plug 5 into my h function. What do you get? Yeah, it'd be 5 squared. That's a real good 5, lady. Minus 1. So that would be 25, 24. Now plug 24 into your f function. It's just one more step. 72. So, like I said, think either Chinese or inside out, right to left. You're going to go to g of 1, then plug that into h, then plug that into f. So this guy, you're going to start with h, plug negative 2 in, whatever you get there, plug it into g, whatever you get there, plug it into f. Okay? Any other questions on your worksheet?